Okay, the
Good evening,
first
everybody.
question. Good evening.
Yeah, Professor Ayorinde welcoming you to another online session in organic chemistry. For today's session, we are going to review for your third exam, that is exam number 3 for the spring 2015 semester. And since you guys are in Professor BAKARE's class, we are going to use one of the third exam from Dr. BAKARE in today's review session. Okay, so to get the session started, we are going to start with question number 6. Okay, what I want to do now, Ishmael, can you go ahead and read question number 6 for us?
Sure. Number 6, suggest structures for the compounds A to J in the sequence of reactions shown below.
Okay, very good, and thank you. Now, this what you have here, you have a series of reactions in which you have we are testing for your knowledge of the reagents and reactions. And so, therefore, this is actually one of the simplest questions in this exam, and we are going to go from the very simple question to progressively increase the difficulty of the question as we go along during the course of this session. So, what do we have here? We have a ketone, and then we have sodium borohydride followed by hydronium ion. Okay, for this set of questions, what is really most important here is for you to know what the reagents do. Okay, so I am going to ask you this simple question here. What does sodium borohydride followed by hydronium ion, what does it do with a ketone? Yeah, you could send your response through the chat window, or you could pick up the mic if you want. What does sodium borohydride followed by hydronium ion, what does it do to a ketone? Okay, very good, excellent, excellent. In other words, what you are saying here, sodium borohydride will transform a ketone into a secondary alcohol. Very good. So let us write the product here. Take this out. So we have sodium borohydride reacting with a ketone to give as you can see here, we are transforming the ketone, which is this here, to a secondary alcohol. Very good. So in this particular instance, all you need to know here is what does this reagent do, in this case the sodium borohydride, followed by hydronium ion. Okay, now that we formed the secondary alcohol, now they want us to react the secondary alcohol with phosphorus oxychloride in pyridine. The pyridine here is just a solvent. Phosphorus oxychloride in pyridine reacting with a secondary alcohol. Now, what does it do with a secondary alcohol? Okay, secondary alcohol in the presence of phosphorus oxychloride. What do you expect to obtain as a product here? Okay. Now, what happens here? Not exactly correct. What happens here? Phosphorus oxychloride, what it does, it will perform what we call dehydration. In other words, to eliminate the element of water from a secondary alcohol or a tertiary alcohol. So in this particular instance, we expect to get this product here. So we are going to obtain an alkene. Notice what happens here. Notice what happens here. What happens here in dehydration? You are going to lose the hydroxide and hydrogen, which constitute the water molecule, and therefore we are going to. Sorry about that. Not that hydrogen. You are going to look at the hydroxy group and the hydrogen that is in this position here. Okay, let me take this back. The hydrogen that is in this position right here. So you are going to lose this hydrogen, and then you lose the hydroxide, and that is why we've now formed the alkene. You notice we formed the alkene between this carbon and this carbon. So therefore, what happens here, phosphorus oxychloride, what does it do? It will dehydrate a secondary alcohol or a tertiary alcohol to form an alkene. Okay? Oh, sorry about that. Let me move this back. Okay, so far so good. Let's take this out. Okay, now let us go to the next one. Okay, let us go to this here. Let's look at this reagent here. Phosphorus tribromide. Okay, okay. Chelsea, you are welcome. I see Chelsea has joined us. Chelsea is asking, is this the first question that we have worked on today? Yes, we started with question number 6. Very good. Ayana, also, you are welcome. Okay, now we have a secondary alcohol. We have a secondary alcohol, which is this product here, and we are supposed to react this with phosphorus tribromide. So what does phosphorus tribromide do with a secondary alcohol? What do you expect to get here? Okay, very good. It replaces the hydroxyl with a bromine atom. Very good. That was Chelsea. Very good. Okay, so therefore, what do we expect to get here? We obtain this product here. Keep in mind, this set of questions here is just simply testing your knowledge of the reagents and the reactions. So this is basically memorization at this point. Okay, so in this particular instance here, we are forming a secondary alkyl bromide, which is this here. Okay, okay. So the point here is each one of these reagents will react with different functional groups to transform the functional group to different classes of compounds. So it is important that you know what those reagents do. Okay, so let us go to the next one. Okay, the next one here, let's do the C. We want to do this one here. Let me take this out. Take this out. Sorry about this. I think I got this moving all over the place now. Okay, so now let us do, take this out, take this out. Now let us do this one here. We want to react the secondary alkyl bromide with this set of reagents here. Okay, can anybody tell us what are we doing here? Okay, we are reacting the secondary alkyl bromide with this set of reagents here. Anybody has an idea what are we doing here? By the way, let me give you a hint here. This molecule here, it is this here. It is an aldehyde, so that is formaldehyde. Okay? Okay, let us see. Chelsea say a primary alcohol on, oh, let me see, is that a question here? A primary alcohol on methyl substituent to the ring is the final product. Oh, okay. Okay, yeah, I got you. Then Ayana said Grignard reaction. Excellent, that is correct. So we are performing a Grignard reaction here. Okay, in other words, that is very good. In other words, what are we doing here? If you look at this here, we look at right here, we are going to form the Grignard reagent, that is magnesium in the presence of ether. So we are going to form the Grignard reagent with this alkyl bromide here. And then once we form the Grignard reagent, that will now react with the aldehyde, and therefore, Chelsea, you are correct. So you are going to form a primary alcohol. Let us see the structure here. So it will be this here. Notice here that this carbon here, this is carbon coming from the carbonyl of the formaldehyde. So anytime you have a Grignard reagent reacting with formaldehyde, what you do, you form a primary alcohol, and that is what this is. Now keep in mind, all we are doing here is simply just trying to find out how much of the reagents you know in terms of their reactions and the product of their reactions with different organic compounds. So this is at this point just pure memorization. Okay, now let us go to the next one. Take this out. Let us do this here. Okay, so what are we doing here? They want us to react PCC in dichloromethane, the methylene chloride here. This is just a solvent. This part of this here is just a solvent. The PCC is the reagent here. Okay, now we have a primary alcohol reacting with PCC. Anybody has an idea? What do you expect to get here? Anybody has an idea? What do you expect to get? PCC reacting with oh no, not exactly. Okay, good, excellent. Okay, oxidizing alcohol to an aldehyde. Now you need to be very careful here. Don't just say oxidizing alcohol to an aldehyde. It will oxidize a primary alcohol to an aldehyde. That is what you need to say. It will oxidize a primary alcohol to an aldehyde. It will also oxidize a secondary alcohol to a ketone. So keep that in mind. So in this case, you are correct. I think that was Chelsea. In this case, you are going to form this product here. Okay, let me take this out of the way. Okay, so what have we done here? This primary alcohol here, we have now oxidized this carbon here of the primary alcohol to the carbonyl of an aldehyde, okay? And that is what the PCC will do. PCC will transform a primary alcohol to an aldehyde. It will also transform a secondary alcohol to a ketone. Okay, so keep that in mind also. Now let us go to the next one. Okay, and that is this here. Okay, so what we have here, we have an aldehyde, and they have given us silver oxide in ammonium hydroxide. The water here, this water and the ethanol, these are just solvents. The reagents are the silver oxide for the most part, and then ammonium hydroxide. Now, what does this do with an aldehyde? What does silver oxide do with an aldehyde? What do you expect to get? Okay. What do you expect to get? Silver oxide with an aldehyde. Produce silver, and no, it produces silver. Okay, carboxylic acid, exactly. Carboxylic acid, exactly. Keep in mind, you need to know what these reagents do. So whenever you have silver oxide in the presence of ammonium hydroxide and you have an aldehyde, what you get is a carboxylic acid. So therefore, this is this here. In this particular instance, specifically, we are going to get the ion, the conjugate base of the carboxylic acid, what we call the carboxylate. But if you say carboxylic acid, that is fine. We are going to form the carboxylate because this reaction here is taking place in a basic medium. So therefore, you are going to form the negatively charged ion of the carboxylic acid. But if you simply if you simply write carboxylic acid and you write the structure of carboxylic acid, that is fine also. Okay. At this point, I know some of you will simply just do this here. That is fine. But more specifically, you are going to form a carboxylic ion, and that is what this reagent will do. So you need to know what these reagents do. Okay, let us go to the rest of question number 6. Let's see here. Trying to move this up. Okay. 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 Now we have what we have there. We have, forget this one here. Let me just take this one out. Don't need this here. There is nothing here. Take that out. Okay. Okay, so now let us go to this reagent here. Right here. Okay. And let us also erase some of this so we don't get confused with all of these colors here. Okay, at this point, what are we doing? We want to react this aldehyde here with this reagent here. Okay, so what is going to happen here? By the way, what kind of reaction is this? What kind of reaction is this? Looking at this reagent here. A secondary alcohol is formed through Grignard. Excellent, great. Okay, in other words, we are dealing with a Grignard reaction here. Very good. Okay, Faith, you are also welcome. So we are dealing with a Grignard reaction, and Chelsea has told us that we are going to form a secondary alcohol. The point to be made here is anytime a Grignard reagent, which is what this is right here, anytime a Grignard reagent reacts with an aldehyde, you form a secondary alcohol. So keep that in mind. Let us write down the product. Okay, so use the green color to be consistent. So we are going to do that this here. Okay, this here. You notice I have the benzene structure here. This is actually this part of the molecule. That is the benzene structure. Okay, so what do we have here? We have reacted a linear reagent with an aldehyde, and then we obtain a secondary alcohol, which is what this is right here. Okay? So keep that in mind. Okay, let us move on to the rest of this question number 6. Okay. We have 2 more, I believe. Yeah, we have 3 more reactions here. Okay, now, what do we need to do here? What are they asking us to do here? We now want to react. Let me take this out. Now we want to react this reagent PCC. Keep in mind the methylene chloride here. This is just a solvent. We want to react PCC with a secondary alcohol. Okay, so what do you expect to get as your product? Anybody? You get a ketone. Very good. Excellent. You get a ketone. Excellent. Okay, the PCC will convert or transform a secondary alcohol into a ketone. Okay, so let us go ahead and write that product, and that is this here. Okay, so now you get your ketone. Okay, so what did we do? What we've done here, reacted a PCC with a secondary alcohol, which is this here, reacting with PCC, and then we obtain a ketone. Very good. Okay. Okay, now let us do this one here, I. This here. What is I asking us to do? To react in this case, we are going to react the ketone with a primary amine. Okay, does anybody have an idea what this is going to give you? Take this out. They want us to react. Excuse me, they want us to react a primary amine, which is this here, with our ketone. Okay, what do you think this will give? Replace N with alkyl. Okay, very good. Okay, with oxygen. Okay, well, we are going to replace the oxygen with the nitrogen. That is correct. And then in this case, we are going to form what is called an imine. Okay, so anytime you see a primary amine and a ketone, and sometimes also an aldehyde, the carbonyl of a ketone or the carbonyl of an aldehyde will react with a primary amine to form what we call an imine. Let us do that here. Just a minute, I'll be right with you. I know somebody asked a question. Okay, so we call this here, this molecule here, and imine. Anytime the imine is whenever you have a nitrogen carbon double bond, that is called an imine, and that happens anytime you have a primary amine, in this case this here, and then a ketone or an aldehyde will give you an imine. Okay, Chelsea, go ahead and ask your question. Okay, do you have a question, Chelsea? You could pick up the mic, or you could just send me your question through the chat window. Anyway, so while we're waiting for your question, let us move on for now. Okay, and that is what you get whenever you have the amine, primary amine. This is a primary amine reacting with a ketone. You get an imine, okay, which is a nitrogen carbon double bond. Okay, now let us do the last question, or the last reaction on this question number 6. Take this out of here. Okay, for this here, what do they want us to do? They want us to use this reagent here to react with this ketone. Okay? Does anybody know what type of reaction is this? Okay, just a minute. Let me see the question that was. Let me go back to the question that somebody is asking here. Okay, I'll be right with you. Let me see this question here. Okay. Chelsea is asking a question. I didn't know you were waiting for me. Does amine or enamine formation require a solvent? Yes, it does require a solvent, but in this particular instance, you don't need to worry about solvent. When you are dealing with organic chemistry lecture, for the most part, do not worry so much about the solvent unless we give you the solvent. Very often in this particular instance, you will find that you need, most organic reactions, you need a solvent anyway. So, but do not worry about solvent at this point. All we are simply giving you is just the reagent, and just know what the reagent will do with the particular functional group. Okay, another question. In other words, we will only see the reaction as an in other words, okay, anyway, the question, the point is you don't need a solvent. You don't need to show the solvent here. Okay. Okay, so let us go to this one here. Here we have, let me go back again. We have this molecule here, okay, reacting with this ketone right here. Now, what type of reaction is this? Does anybody have an idea? What type of reaction is that? It forms a tertiary, a Wittig reaction, yes. This is a Wittig reaction. This is a Wittig reagent right here. Folks, you need to know your reagent. Knowing your reagent is the beginning of organic chemistry. This here is your Wittig reagent, okay? So the Wittig reagent, what it does is to react with the carbonyl of a ketone or the carbonyl of an aldehyde to form an alkene, okay? That is what the Wittig reagent will do. It will react with the carbonyl of a ketone or the carbonyl of an aldehyde to form an alkene. So therefore, in this particular instance, let us take all of this out. Okay, so in this particular instance here, you look at this here, this carbon here, this carbon of the wheatic is going to replace the oxygen of this here, so you are essentially now going to form a carbon-carbon bond. Okay, so what will be the product? Let us now give you the product. Okay, Sheung has just joined us. Sheung, you are welcome. Okay, so you get this product here. Okay, so what you see here, this carbon here is now this carbon right here. So the carbon of the wheatic, what it does is to replace the oxygen of the carbonyl of a ketone or the carbonyl of an aldehyde to form a carbon-carbon double bond. Okay, and that is what we have here as the product. Okay, so far, yes. Ishmael, go ahead and ask your question. Go ahead and type it out on the chat window. Yeah, okay, go ahead. Pick up the mic, okay.
Okay, yes. I actually have a question about the reaction to the left. So the two hydrogens attached to the nitrogen don't create a water product, yes, by any chance?
Yes. What happens here? Yeah, you're asking for the reaction mechanism. What happens here in this particular reaction here? In this particular reaction here, there is what we call actually something that is fairly missing here. This reaction is catalyzed by acid. So you are going to lose water here eventually. But the point to be made here is anytime you see the primary amine reacting with the carbon-carbon carbon-oxygen double bond, you are going to form an amine. Okay, so because this reaction will be catalyzed by hydrogen ion. Yes, go ahead, Ayana. Ayana, do you have a question? You can pick up the mic if you want. Okay. No question. Okay. Let us move on. Okay, now let us go to. Yes, go ahead.
Hello?
Yeah, go ahead. I cannot hear you.
Oh, okay.
Yes, go ahead.
I know that which is
Oh, I tell you, I see where you, okay, I think my mistake here. I see where you guys are getting a little confused. Oh, I'm sorry. This is not here. I see, that's why I'm sorry about that. Okay. That hydrogen is not supposed to be there. Okay. Okay, you type in I'm going to type it. I know that to make wheatic reagent, you have to use an alkyl halide. Can you use a secondary alkyl halide or just, yes, to make a wheatic reagent, you could use a secondary alkyl halide or a primary alkyl halide. That is correct. In this particular instance here, what they started with is a primary alkyl halide, okay? But you could also use a secondary alkyl halide. Okay, now let me go back to this question here. I see Ismail You asked me a question earlier whether the two hydrogen here is going to be used to form water. Yes, that is correct, because both of those two hydrogen will be gone. You notice here there is no longer hydrogen on this nitrogen here. So that was my error earlier. Okay? Okay, so now let us go to question number 4. Okay, let us see here. Was that Ayana? Ayana, can you pick up the mic and read question number 4 for us? Okay, if your mic is working. About Faith, is your mic working? If your mic is working, can you go ahead and read question number?
Achieve the following transformation employing Grignard reagent.
Okay, thank you. That was Ayana. Okay. Okay, now the question here is outline a reaction scheme to show how you will achieve the following transformation employing a Grignard reaction. Now you notice here, we are now getting to more complex problem. This is a synthetic problem. And for the synthetic problem, of course, most of those reagents we use in question number 6 that we just did, you will find that we're going to find them very handy. So that is why I kept telling you it is important that you know what those reagents will do. Now let us do an analysis of this problem here. Okay, so what do we have? They want us to use a Grignard reagent, okay? I'm assuming that we're going to use a Grignard reagent on this part of the molecule. Now, if you also take a look at the starting material and the product, take a look at the starting material and the product, you will find that if you take a look at the starting material, this here, you will say this here will correspond to this part of the molecule. So therefore, if you make a Grignard reagent from the starting material, now, can anybody tell me, given the fact that we are going to form a tertiary alcohol, if you make a Grignard reagent with the starting material, does anybody know what kind of other starting material do we need to use to react with the Grignard to form this product here? Given the fact that we are forming a tertiary alcohol. A ketone, exactly. We are going to form a ketone. Okay, excellent. So if that is the case, then we say what will be the ketone? Okay, the ketone part will be this part of the molecule right here, right? Okay, so therefore it is almost obvious at this point that the ketone will be something like this here. That would be how many carbons here? 1, 2, 3. No, one more carbon. Okay, so your ketone will be this here. Okay. Now, if you agree with that, can you give me a happy face? If you agree that your ketone will be this here, give me a happy face. Okay, very good, very good. Okay. So therefore, what we need to do? What therefore do we need to do? We need to form a Grignard reagent first, right? Now, the problem here is if you simply go ahead and form a Grignard reagent with this starting material, you are going to have a problem because you cannot form a Grignard reagent in the presence of a ketone. This molecule here has a ketone. So you cannot form a Grignard reagent in the presence of a ketone. So therefore, what do we need to do? Does anybody have an idea? What do we need to do at this point? Take this out of here. Anybody has an idea? What do we need to do in order for us to perform this synthesis? Protect the carbonyl. Excellent. Okay, protect to make, in this case, we are going to form a ketal. You are going to protect the carbonyl to form a ketal. The ketal comes from a ketone, and acetal comes from aldehyde. Okay? So you are going to protect the carbonyl to form a ketal. Now, if you form a ketal, let me show you, for example. This would be an example of a ketal. Okay, the ketal, you have two ether functionality joined to the same carbon atom right here. This is an ether, this is an ether joined to the same carbon here. So we say this is a ketal. Now, once you form a ketal and you have dilute acid, you add dilute acid to the ketal, what happens? Ketals are very unstable under dilute acid condition, so the ketal will simply just open up to give you back your ketone or aldehyde. Okay, so that is the beauty of using a ketal to protect the carbonyl, because you could perform all of your other reactions under non-acidic conditions, and then once you add the acid, you regenerate your ketone. So let us see what are we going to do here. Okay, you guys have already told us we need to form a ketal. Okay, so that means you need to know the reagent for forming your ketal. So let us start the synthetic scheme. Okay, to form your ketal, you use this here. You use ethylene glycol. Ethylene glycol, that is the molecule that you use for your antifreeze. Okay, generally you use this in a use catalytic amount of acid to perform this reaction. Keep in mind we say catalytic amount of acid, not dilute acid. So once you do that, you get your ketal. So let us go ahead and write this here. From that, and then of course this here. Okay, so we now have this. No, let me write this better than that. It'll be written better than this one here. Okay. Okay, that's better. Okay, now we have the rest of the molecule. Okay, so now we form our ketal. Now at this point, what do we need to do now at this point? Now that we form the ketal. Anybody has an idea, what do we do next? Now that we form the ketal, what do we do next? Form the Grignard reagent, okay? Now we form your Grignard reagent. No, form your Grignard reagent. Okay, to form your Grignard reagent, of course, you need magnesium in the presence of ether. Okay, so now we're now going to form this. We see have the ketal in place. We now have that. We have our Grignard reagent. Now that we have our Grignard reagent, what do we now do? We react the Grignard reagent with the appropriate ketone, step 1. Then step 2, you add the hydrogen ion. Okay. And what do you think will happen? We simply now come straight to here. Because the moment you now add the hydrogen ion, keep in mind, at this point, the Grignard reagent will react with this ketone, okay? And then once you work up the reaction with hydrogen ion, you are also going to open up the ketal, and therefore gives you back your carbonyl of the ketone, okay? Do you follow this? In other words, how many steps do we have here? How many steps? 1, 2, actually 3 steps. It's a 3-step synthetic scheme. Okay, but the more important point here is you must recognize that you need to protect the carbonyl of the ketone before you make your Grignard reagent. Now, if you follow this, give me a happy face. Okay. Okay, very good. Okay, very good. So let us move on. Number 7. Let's go to question number 7. Okay, let me see, who can I call on? Faith, if your mic is working, can you read question number 7 for us?
Synthesize the following alcohols starting with cyclohexane and bromocyclopentane as the organic starting materials. Show all reagents and all intermediates in the synthesis.
Okay, thank you, Faith. Okay, so now once again, this is another synthetic problem, which means that you need to know all of those reagents some of those that we use in question number 6. Okay, so what are we supposed to do here? We have bromocyclopentane, which is this here, bromocyclopentane, and then we have cyclohexene, which is this here. This is bromocyclopentane, which is this right here. And we are supposed to use both of these here to synthesize this tertiary alcohol. Okay? Now, let us do some analysis here. I will ask you a few questions here to help me out. Okay, let me take this out. If we take a look at this here, of course, what type of reaction do you think you need to use here? We need to form a new carbon-carbon bond. What type of reaction do you think you need to use? I think we've used a lot of it already. Anybody? Okay, Grignard, exactly. Very good. We need to use a Grignard. Okay. Okay, if we need to use a Grignard, let me number this. Let us say this is carbon, this is molecule 1 and molecule 2. Which of these molecules here are you going to use to make your Grignard? 1 or 2? 2. Excellent. So we make Grignard from here. Very good. So therefore, you guys already told us we are going to make Grignard from there. So Grignard, of course, in the presence of ether. By the way, if you write Grignard and you do not put the solvent ether in there, that would be fine. Okay, so you are going to form your Grignard. We'll come back to this because we are going to use it later. So we form our Grignard from the bromocyclopentane. Now, so now what do you think here? We have a tertiary alcohol. We have a tertiary alcohol as a product. Okay, so what type of molecule, what class of compound would the Grignard react with in order for us to form a tertiary alcohol? A ketone. Excellent. We are going to have to react this Grignard here with a ketone, which is to say that this molecule 1 here, which is cyclohexene, must be converted to a ketone. Do you follow that so far? If you do, give me a happy face. Which means that this must be converted to a ketone, this molecule here. Okay, very good. So therefore, how do we convert an alkene to a ketone? Anybody has an idea? How do we convert an alkene to a ketone? How will you convert an alkene to a ketone? Okay. How do we want? Okay, let us see here. Somebody is giving some mind. First, make it an alcohol, then oxidize. Excellent. Okay, that is correct. First, make it an alcohol, then you oxidize the alcohol. Okay. You guys should know the reagent to use. I will give you some help here. You could use There are so many reagents you can use, but you could use borane followed by hydronium ion. Okay, and that will give you your alcohol. Okay, because what does this reagent do? This reagent here, what it does, borane followed by hydronium ion, what it does is to add the element of water across a carbon-carbon double bond. So you add hydroxy group and hydrogen across the carbon-carbon double bond. So we form a secondary alcohol. So at this point, what do? Just like you guys already told us, we now use excellent PCC. We use PCC to oxidize the, let me use this one here. We use PCC to oxidize the alcohol to a ketone. Okay, and now once we do that, let me get all of this out of the way. Now keep in mind that we've already made our grignard from this molecule here. We've already made our grignard from here, so we're now going to use the grignard. So therefore, what are we going to do? Let me just clear all of this here, so that we make some room to clear all of this. Clear all of this. We now take our grignard. We add the grignard with this. And that grignard will be this here. And that is step 1. And then step 2, we follow that up with hydronium ion. Okay? Okay, so that is how we form the tertiary alcohol. Do you follow that? If you do, give me a happy face. Okay. Okay, good. Excellent, excellent. So this is how many steps are we using here? Actually, this is how many steps. 1 step here. Okay. 2 steps. And of course, the 3rd step will be the fact that we made this grignard from here. Okay. Okay, so we've done question number 7. Let us go to question number 8. We're increasing the complexity of this question as we go along. Okay, let me see here. Chelsea, can you, I don't think I've heard you talk yet. Can you go ahead and read question 8 for us? Oh, your mic is not working. Okay. Okay, go ahead. Ishmael, go ahead and read question 8 for us.
How would you prepare N-ethyl N-methyl hexanamide from pentanoic acid?
Okay, excellent. Thank you. How would you prepare N-ethyl N-methyl hexanamide from pentanoic acid? Very good. Thank you. Chelsea, you were asking, I saw that you sent me a text message asking me where is the mic. If you look at the, if you can see my cursor right here, okay, that's where the mic is. And anytime you want to talk, just click on that, and then you can talk to me. Okay, so we want to make our N-ethyl N-methyl hexanamide from pentanoic acid. Okay, so let us start off by saying what the structures of these are. The structure of pentanoic acid first. So this is also testing your knowledge of the of nomenclature. Okay, so that's pentanoic acid. And they want you to start with pentanoic acid and make this molecule here, the N-methyl ethynamide. Okay, so we have this here. Change the color here. Let me do that better than that. Okay, that is what they wanted to make. Okay, so let us look at this. Let's analyze this problem here. In the starting material, how many carbons do you have in the starting material? Anybody, how many carbon atoms do you have? 5. Very good. So you have 5 carbon atoms in the starting material. It's 1, 2, 3, 4, 5. How many carbons do you have in the product? How many carbon atoms? Okay. No, in the base name. Okay, you got the idea. Okay, in the base name of the product, you have 6 carbon atoms. Okay, which is this one here. 1, 2, 3, 4, 5, 6. So what this tells us is somehow we need to extend the carbon chain of this starting material by 1 carbon atom. You need to do that before you can begin to attach nitrogen to a carbon atom. Okay, so we need to form a new carbon-carbon bond. Okay, so based on your knowledge so far, you have a few reactions that you can use to generate a new carbon-carbon bond. So what reaction are you going to use here to extend this carbon by 1? Anybody has an idea? Okay, let me give you a hint. Okay, what do we have here? Let me start with this here. You have pentanoic acid. Okay, in order for us to use those reagents that we know the linear reaction to extend the carbon chain by 1 or many carbon atoms, depending on what kind of linear you are using. We could also use a Wittig reaction to form a new carbon-carbon bond. So in this particular instance, I want to say, let us try the linear reaction. But to do the linear reaction, you need to form an alkyl bromide. So the first thing that should come to your mind is, if you need to form the alkyl bromide, this molecule here, pentanoic acid, need to be converted to an alcohol first. Okay, oh, somebody's giving me okay, very good, thank you. Okay, reduce, okay, Chelsea say reduce the carboxyl to OH, okay, then to bromide. Okay, excellent. I think, okay, I think Chelsea has given us the answer. So let me just write down the answer that Chelsea has given us. So you're going to form lithium aluminum hydride as your reducing agent. Step 1, step 2, you add hydronium ion. And therefore, that gives you this here. That gives you this here. Now, let me just go ahead and use the let's save ourselves some work here. Let's do the bond line structure here. Okay, so that will give us this here. 1, 2, 3, 4, 5. Okay. Okay, so that will transform the pentanoic acid to this primary alcohol So that's 1, 2, 3, 4, 5. Okay. Now once you get that, then you take, just as Chelsea said, we should do phosphorus tribromide. In other words, you need to know what reagents to use to transform one functional group to another. You need to memorize those reagents. There is no way around it, okay? Like I keep telling you, knowing your reagents is the beginning of knowing organic chemistry. Okay, so now we have this. Notice what we've done here. Phosphorus tribromide will transform a primary alcohol and sometimes a secondary alcohol to alkyl bromide. And that is what we have here. Now once you have this, then we have the linear reagent. So we form our linear reagent here with ether. And once we do that, then we could dump in the formaldehyde. This is what Chelsea told us to do, which is correct. Then step 3, we add the hydronium ion. And what does that give us? That gives us this here. So now we extend the carbon chain by 1. That is 1, 2, 3, 4, 5, 6. We now form the primary alcohol. Now that we form the primary alcohol, keep in mind, what class of compound is this? The product that they want us to make this year. Okay, what class of compound is that? Anamide, very good, which is a carboxylic acid derivative. And those carboxylic acid derivatives, to make them, of course, you generally have to go through the carboxylic acid first. Okay, so therefore, what do we need to do with this primary alcohol that we formed here? What do we need to do with it? Oxidize to carboxylic acid. Very good. So we need to oxidize that to carboxylic acid. Let us oxidize to carboxylic acid. Okay, now once you oxidize that to carboxylic acid, then the next thing that we'll do, you could react the amine, because if you take a look at this product here, this part of the molecule here has to be your amine, okay, which will be this here. Okay, so in other words, we are going to use a secondary amine to react with either a carboxylic acid or a carboxylic acid derivative. Did you guys use what you call DCC? Did you use this in your class? Oh, I'm sorry about that. Did you guys use DCC in your class? No, not PCC, no. Okay, this is where you don't know about DCC. Okay, let me take that back. Now, the reagent you need to use here to go from a primary alcohol to carboxylic acid, you could use, I almost forgot that, let me put this in here. You use chromium anhydride in dilute acid or any of the chromium derivative. Okay, so you could use chromium trioxide in hydronium in dilute acid or chromic acid. You could also use that. Anyway, if you react the chromium trioxide in hydronium ion with a primary alcohol, you obtain your carboxylic acid, and then from your carboxylic acid, you now take your carboxylic acid, react your carboxylic acid with thionic chloride, If you react carboxylic acid with thionic chloride, let me get all of this out of here. With thionic chloride, you get this here. You replace the hydroxy group with a chlorine, so you are going to form an acid. Okay, so let me get this out of here. Okay, so you react your carboxylic acid with a thionic chloride. This is called thionic chloride. Okay, did you guys use thionic chloride in your class before? Yes or no? Yes, okay. So you react the carboxylic acid with thionic chloride. That will give you the acid chloride, and then when you then take the acid chloride and then you react with this here, this amine, react with this amine right here, then you get the final product, which is this here. One, two, three, four, five, six. Okay. Now, if you follow that, give me a happy face. What have we done here? There's a lot of steps here. There are a lot of steps here. Let me go ahead and erase some of these numbers to not to cause confusion. Let's see here. Okay. How many steps do we have here? Okay, so what is the first thing we did? We took the carboxylic acid, reacted with lithium aluminum hydride. That is one step. And then we got the alcohol from that. So this reagent here will transform the carboxylic acid to a primary alcohol. Then we took the primary alcohol, we reacted with phosphorus tribromide. That is step 2. And then we got the alkyl bromide, primary alkyl bromide. Actually, in this step here, we actually combine two steps here. That actually two steps here. So I'll say step 3 and step 4. Step 3 is when we reacted the alkyl bromide with the, you form the Grignard reagent. From the Grignard reagent. And once we form the Grignard reagent, then we reacted the Grignard reagent with the formaldehyde. Then we follow that up with hydronium ion to work up the reaction. And that gave us the primary alcohol right here. And that is how we extended the carbon chain by 1. So that gave us this primary alcohol here. And then once we obtain the primary alcohol, we then did another step. That would be step 5 right here. So we oxidize the primary alcohol to carboxylic acid using chromium trioxide in acid medium. So we got the carboxylic acid. And then upon obtaining the carboxylic acid, we reacted the carboxylic acid with thionic chloride. So that would be step 6. So there's a lot of steps to this reaction here. And then finally, we then reacted the amine, which is this here, with the acid chloride, which is this. That is 7 steps. So there is a lot of steps to this reaction. It's not as innocent. This question is not as innocent as it looks. Okay. So now let us go to, I think that was question number 8. Now let us go to 1. This one is very interesting question here. Okay, very interesting. Well, what time do we have? Okay, yeah, let's spend about 15 more minutes and then we'll be out of here. Okay, let's see. Ayana, if your mic is working, can you read question 1 for us?
As an undergraduate research assistant, you have been asked to prepare 3-methyl-3-pentanol, and you're given excess ethanol as starting material. The only reagents and solvents you have available for this synthesis are pyridinium chlorochromate, magnesium, phosphorus tribromide, dilute aqueous acid, dry diethyl ether, and dichloromethane. Outline a rational reaction sequence to show how you would carry out this synthesis with the reagents given.
Okay, thank you. It does seem like there's a lot to this reaction, but it's really it's a very interesting problem. Okay, let us take a look at it. What we have here, see, as an undergraduate research assistant, you have been asked to prepare 3-methyl-3-pentanol, and you are given excess ethanol as starting material. That, in other words, what they want you to do here, your only source of carbon in this reaction is ethanol. That's what they are telling you, okay? So we have ethanol as the only source of carbon atom here in this synthesis problem. Okay, then the only reagents and solvents you have available for the synthesis are pyridinium chlorochromate, which is PCC. Pyridinium chlorochromate is PCC. By now, you guys know what that reagent will do. Okay, magnesium. You also know where that is taking you when you see magnesium. Phosphorus tribromide. You should also know what that should do. Dilute aqueous acid, okay, which is your generic hydronium ion we use all the time. Okay, these are all of the things that you need to use in order for you to make this molecule here. Okay, let us write the structure of that molecule. It's also testing your ability, your knowledge of nomenclature here. Okay, so they want us to go from ethanol as the only source of carbon atom to make this molecule here. 3-methyl, let us do this here. I think this should be out of here. Okay. So they say 3-methyl 3-pentanol. Okay. Very good. Okay. Let us do the analysis of this problem. If you look at this here, given the fact that we only have 2 carbon atoms in ethanol, right? Then I will make the assumption that this carbon atom here could come from ethanol. I will also make another assumption that this here could come from ethanol. And this question here, this is kind of question that requires a lot of critical thinking. Okay? But critical thinking, given the fact that you already know your reagents, without knowing your reagents, you really cannot think critically, okay? That is why it is important to know those reagents. I will also make another assumption that these 2 carbon here must also come from the ethyl alcohol, because what they've told us here is that the only source of carbon atom in this synthesis is the ethanol, which is this here, okay? So if that is the case, they've also told us we can only use the following reagents: PCC, magnesium, phosphorus tribromide, and this here. Okay, so now let us go about how do we do this. What I would suggest that we do here is to do a retrosynthesis In other words, start from the product and go backward to the starting material. Okay? Let us do that. So the first question I will ask you, you have a tertiary alcohol, right? If you have a tertiary alcohol, can you give me what type of reaction would you use to make a tertiary alcohol? Anybody has an idea? It's a very common reaction. What type of reaction? Greener. Excellent. Greener with a ketone. Once you understand that, then this problem is solved. Okay, so let us go to the next page and see how we can solve this. We are going to use retrosynthesis here. In other words, go backward. Oh, well, that's not what I want to do. Okay, this is the product this is the problem that we have to deal with. We have this here. Okay. Now I want to make a tertiary alcohol. Okay. Now if you want to make a tertiary alcohol, there are many ways in which you can make a tertiary alcohol starting from this here. But let us see if we can do this. Supposing we say we'll do this here. We will want to take this ketone. Since you guys have already told us that we need to use a ketone, I want to take that ketone, then I want to use, no, okay, yeah, very good. Somebody is saying that we could also use an ester. No, you cannot use an ester. Given the fact that if you go back, let us go back, that is question number 1. Keep in mind, these are all of the reagents they told you to use. See, this question is a very tricky question. These are the reagents they told you to use. None of these reagents will be able to give you an ester. So that is why you cannot use an ester. Okay, it's a very tricky question. And that is why I told you earlier, this is a question that you really require to think critically. Okay, let us go back to, okay. So we have, so I would say we use this Grignard reagent. Step 1, then step 2. Okay, if we do that, so what do we have? We have this. We have this product here. This Grignard reagent reacting with this ketone will give us this tertiary alcohol. So far, so good. Do you agree with that? Yes or no? Or give me a happy face. Okay, keep in mind what we want to do is go back to the starting, to do a retrosynthesis here, going back from this product to the starting material. Now, if that is the case, then we could say this ketone here, we could obtain this ketone from an alcohol. Okay? We could obtain this ketone from an alcohol. My shed is messing up my writing here. And what do we need to use for the reagent for this? We use PCC. Okay, keep in mind PCC will take you from a secondary alcohol to a ketone. Okay? Now, if that is the case, because PCC is one of those reagents that they gave us to use. Now, the next question is, how do you make this secondary alcohol? That is the next question. How do we make this secondary alcohol? Can anybody tell me? From a grignard. Excellent. We make it from a grignard. Okay. We've already have this grignard here, so we could use that grignard, right? We could use that with, say, an aldehyde. A grignard with an aldehyde will give you a secondary alcohol. You need to know that. Okay, so I will say, okay. Go back again. So I will use okay, I will use an aldehyde. With a grignard to step 1, and then step 2. If you notice here, this grignard here, that is the same grignard, okay? Okay, so the grignard, this grignard will react with this aldehyde to form this secondary alcohol. So far, so good. Then the next question you want to ask me is, how do we now form the aldehyde? Keep in mind you have to start from ethanol. Exactly, PCC. Okay, so now we take the go back with our retrosynthesis again. Say, okay, we could do that, and that we could take the that is your ethyl alcohol. That is the starting material, and we could react that with PCC. Okay, so that gives us the aldehyde. Once you gives us the aldehyde, then the next question you want to ask me is, how do we form the grignard from ethyl alcohol? How do you form the grignard from ethyl alcohol? Of course, you can form the grignard from ethyl alcohol by simply doing this here. Okay. Okay, exactly. Phosphorus tribromide. Exactly. So you now do you guys already got the idea. So you could form this here by reacting this with phosphorus tribromide. Step 1, and then after that, you then do your grignard. Okay? Okay, and that's how we form the grignard. So now we've basically finished everything. Let us see how many steps have we used here. We started from the ethanol. We reacted the ethanol with PCC, so that is step 1 to give us the aldehyde, propanol. And then once we do that, we react the propanol, which is the aldehyde, with this grignard here that we have just formed right here. Okay, so that will be step 2, and that gives us the secondary alcohol. And then from the secondary alcohol, we react with the PCC. That is step 3 to give us the ketone. And of course, from the ketone, we react with the grignard, and that is step 4 to give us the final product. To see here. Okay. The 4 steps. In addition to those 4 steps, we did the grignard, which will be another step, which is 5 steps. So in this particular instance, if you notice here, all of these reactions that we use in this synthetic scheme, all of the reagents you already know. Without knowing those reagents, you will not be able to do this. So please keep in mind, make yourself a table of reagents and what those reagents do, because without you knowing what the reagents do, you cannot do anything in organic chemistry. Okay, let us do one more before we leave. Let us do 2. I think it's, we spent almost 90 minutes here. 2. Okay. Okay, let us see. Ishmael, can you go ahead and read question 2 for us?
Propose a synthesis of dimestrol starting from P-methoxypropiophenone as the only source of carbon.
Okay, thank you. So we do this and then we call it a day. Okay, this molecule here, dimestrol, is a sex hormone. Let us see this here. Okay, so it's a very important biological molecule. Now, what they're asking you to do here, starting from this molecule here, I notice Faith is going back and forth. I think you might be having problem with your internet. Okay, they want us to start with this starting material and to make this this product here. This product right here. Okay. Now let us do some analysis here. What do we have here? Take this out. If you look at this molecule here, the starting material, let us look at this starting material right here. Let's look at the product. If you look at this part of the product right here, okay, it looks very much like this here. And the same thing, the other part of it, this part here. No, let me take that. This part here also looks like this here. So it's almost as if you are joining this molecule here, taking two of them, you're joining them together. It's also joining them together where you have the carbonyl. Now, let me ask you this. You want to go from a carbonyl to a carbon-carbon double bond. Do you know any reaction? I know there is one reaction. I'm sure you've done this in class already. Do you know any reaction that could go directly from a carbon-oxygen double bond to a carbon-carbon double bond? Can you give me the name of that reaction? Wittig reaction. Excellent. Once you know that, then this problem is solved. Okay, so you have to use a Wittig reaction. Use a Wittig reagent here. Okay. If you are going to use a Wittig reagent, let me give you a little bit of background on that, because this molecule is so large. I would like to let's take a look at the Wittig. For you to make a Wittig reagent, you have, let's start with this generic molecule here. We could use a primary alkyl-bromide or a secondary alkyl-bromide. You take it, in this case I am using a primary alkyl-bromide. You react the primary alkyl-bromide with this molecule here, triphenylphosphine, called it triphenylphosphine, and triphenylphosphine will react with this primary alkyl-bromide or secondary alkyl-bromide to displace the bromine in an SN2 reaction. So now you get this product here. Now the phosphorus will now be positively charged. Okay. Now once you get that, get this out. You now take butyllithium. Butyllithium is going to be used as a base here, because what happens here, because of this positively charged phosphorus here, it is fairly easy to remove this hydrogen here because it will be fairly acidic. Okay, because the positively charged phosphorus will stabilize the conjugate base. So therefore you get this here. We remove one of the okay. Use this. Sorry about that. Okay. So we remove one of the hydrogen here, and then of course we see have the phosphorus here. Now this molecule here we call the ylic. And this is negative. This carbon is now negatively charged. Now this carbon here, you can now react that with a ketone. Can now react that with a ketone. So now this carbon will simply now join to this carbon here that is attached to the phosphorus. I think we did this before. One of the problems will now replace the oxygen. So now you're going to form your carbon-carbon double bond, and that is your Wittig reaction. So the product therefore will be this. Okay, keep in mind at this point, this part of the molecule here now, that is this part here. So what have we done? We simply use the ylic to replace the oxygen atom here. Okay, I've been giving you that information. Let us now go back to question number 2. Okay? Okay, so what do we need to do here? We know that we need to make Wittig. To make your Wittig, you need an alkyl bromide. Okay, so to make your Wittig, you need the alkyl bromide. So what is the first thing you're going to do with this starting material? Anybody want to give a guess? What is the first thing you need to do with this starting material? Keep in mind, we need to form the alkyl bromide. We want to make a Wittig. Okay, so you need to, of course, okay, give you a hint. You need to convert, okay, make the Wittig, but to make the Wittig, you need the alkyl bromide. So you need to convert this to a secondary alcohol first. Okay, you need to convert to a secondary alcohol. And what reagent can you use to do that? You use sodium borohydride. Step 1, you guys already know that reagent. And step 2, hydronium ion. And so therefore we convert that molecule to and this will become, okay, now we form the secondary alcohol. What do you think we do from here? We want to form here, okay, convert to, exactly. Keep in mind, you know this reaction already. So this is another case of doing some critical thinking. Phosphorus tribromide, and then that gives us the Okay, and then of course we have okay. Now once you form that, then you form your Wittig. At this point, this is where you form your Wittig. Okay. So now let us just skip some steps. We have the triphenylphosphine. Then we follow that up with butyllithium. Okay, once you add the butyllithium, now you form your Wittig. And then, what is the next thing you do? You now react the Wittig now with this here. Okay, which is your, okay, just to complete this, let me go ahead and put it right here. And of course, this is the ketone is here. Okay. Okay. So what do? The Wittig that you obtain here, the Wittig that you obtain at this point right here, that Wittig now is used to react with this ketone here, which is this here, to form your final product, which is right here. Okay. Okay. Keep in mind what does the Wittig do? The Wittig allows you to go directly from a carbon oxygen double bond of a ketone or a carbon oxygen double bond of an aldehyde to form a carbon-carbon double bond. Okay. By reacting the ketone or the aldehyde with a Wittig reagent or yelid, what we call the yelid, then you are able to go directly from an aldehyde, the carbonate of an aldehyde, or the carbonate of a ketone to a carbon-carbon double bond. So is there any question? I think we have spent over 90 minutes now. It's about time for us to leave. Any question before we leave? Okay. So I want to thank all of you for being here so late, and for I think a few of you are still here with us. Until I see you again, I will say so long, and I will be posting the video for this by Saturday. I will post the video by Saturday, and then also I will be here in my office at Howard University on Tuesday after 2 p.m. just in case some of you may want to get the original video from me. So if you want to do that, just bring your flash drive. I will give you the original video. And then just in case you also want to ask me any question before your exam on Wednesday, I was told that your exam is on Wednesday. That is April 1st. So until I see you again, I say so long. So enjoy the rest of your evening.